some key ideas students will need to know and understand from Unit 6, Day 8, Lesson 4A, Review, Expanding, Factoring, and Combining Like Terms. This is a 7th grade lesson that addresses the 7EE1 standard. And this lesson really hones in on the idea of using the distributive property to help us write equivalent expressions. This standard is going to be super important for students to understand as we delve deeper into the quadratics unit, because students will begin to take the distributive property, the idea of factoring, and the idea of expanding, and actually apply that to quadratic expressions and multiplying binomials, factoring trinomials. And so, although this was taught in prior years, we want to spend this chunk of time reviewing it so that students have that solid foundation before we go into that next part of the unit. And so, what I'm going to talk about for this unit, for this video, is this part of the Explore and utilizing area models to actually go ahead and factor and expand expressions. Before we jump into that, though, I do want to point to slide 20, which gives you some really great additional support around the definitions of expand and factor. And so, I like to think of expanding as multiplying, and I like to think of factoring as kind of dividing. Factoring is like undoing an expansion, a distribution. So in this situation here, when we have 5 times the quantity of 4x plus 7, that's a distributive property problem that students should have had in 7th grade and maybe even been exposed to in 6th grade. It's important when you're reading it to name that it's 5 times the quantity of 4x plus 7 or 5 groups of 4x plus 7. Just saying 5 times 4x plus 7 is promoting this misconception that you're just multiplying 5 by the 4x. And believe it or not, that's one of the biggest misconceptions students have. They'll only distribute to one term. So in this situation, if you really want to push conceptual understanding and you see someone struggling, you can go all the way back to 6th grade when we saw that 5 groups of 4x plus 7 is really just 4x plus 7 5 times. Right? And so then we have 4x 5 times and 7 5 times. So it's just a shorter way to write that, right? Repeated addition we can represent as multiplication. And that might help kids who are really struggling to understand what this means or what steps to take. Factoring is undoing expansion. It's undoing the distributive property. So the biggest issue that kids have with factoring is they're wondering, okay, what is the GCF? What is the greatest common factor here between 20x and 35? This is a pretty simple one, and most kids will see it's 5. But if they're struggling, you can actually have them go ahead and write out the factors. Right, 1, 2, 4, 5, 20, 10, and 20, and x. And then they can do the same for 35 and see that there is that like factor of 5. And really emphasizing, in this situation, there is just 5 is the only factor, but really emphasizing that you want to find the greatest common factor. Okay? And then it's also important for students to understand the idea of a term, because this language will be used regularly, and if a student doesn't know what term means, they're going to start to get really confused by what's happening. Okay. And again, this is vocabulary they should know, but might be worth reviewing. And so, again, like I said, we're going to focus on how to use these area models when executing a lesson like this. So, let me just pop the screen up. Yep. So these are the skills this lesson reviews, like we mentioned, and we really want to reinforce the understanding of equivalent expressions, that these are just multiple ways to represent the same expression. They have the same, if you substituted a number into the expression, you'll get the same response, the same answer, no matter what representation you're using. Okay, and so if we're expanding an expression using an area model, what you can do is you would just line up the expression in this little area model box. Negative 2x times 3y and negative 2x times negative z. This is an area model because we're actually finding the area of each box. Negative 6xy, right? And students get really confused here. We can multiply unlike terms. That's a point to emphasize for students. We can multiply them. And then here we have 2xz. Another thing to point out to students is this is like negative 1z. -1 times -2 becomes a +2. And there's our answer. Okay, and then you can even push students. What's another way we can write this, right? We can also write it like this. That's not wrong. But typically we go in alphabetical order when we're writing things in standard form, and in this situation the y comes before the z, so it kind of gets that y to be that first term, that -6xy term to be first. Oops. And then if we're going to use area models to factor, we're just working backwards like I said. So there's the 6a and the -2b. That's the area of each box. And like I spoke about earlier, you can encourage students to kind of make a little space where they're writing the factors of each term and then finding that common factor, that greatest common factor. That's going to be the height of the box. 2 times what is 6a, that's 3a. 2 times what is -2b, that's -b or -1b, but we like to simplify it as -b. We don't need that one there. And then here's our simplified, there's our expanded, our factored form. Okay? And so we did this already. So where are we going with this? Well, we're going to the point where we're going to actually use area models to multiply binomials and or to factor trinomials and quadratics. And so here's an example of what that might look like, just so you can see where we're going. And so you see in this situation, those two terms cancel out and we get x squared minus 9. So for students to be able to get to this level, it's important that they're able to understand the slides on the previous slides. Okay. So in summary, it is really important for students to have an understanding of the distributive property and using models such as the area model to both distribute and factor so that they can be successful in future lessons within the quadratics unit. Okay, thank you.